A composition of two functions has a symbol that looks like this. It says f of g of x, and we read it as f of g of x. An alternate symbol that we use for compositions looks like this. It's f with a little circle and then a g, kind of looks like fog, f of g of x. So either one of those symbols is the symbol for a composition of two functions. So when we do a composition, it's an operation that we do with two functions, and we do the composition and the range of one function becomes the domain of another function. So the domain of the new function, the new composition, is the set of all x values such that the x in the domain of g and g is in the domain of f. Okay, so we're going to start with compositions involving tables. So I'll give you a table called G, a table of values called F, and it's like an XY table. One's called F and one's called G. And we're going to find F of G of 2. F of G of 2 is done like this. We're going to start on the inner function. So in the composition, the function that's on the inside we'll call the inner function, and the function that's on the outside we'll call the outer function. So we're going to start with the inner function and find g of 2. So we go to the table called g and we find g of 2. G of 2 is 1. So that tells me that I want to find f of 1. So I go over to the table that's called f and I'll find f of 1. So I see that f of 1 is 7. So I can say that f of g of 2 is 7. Now let's do the next one. We want f of g of 5. So we're going to start on the inner function, find g of 5. So the first thing we're going to do is we're going to go to the table called g, find g of 5. G of 5 is negative 3. So now we're going to find f of negative 3. So we're going to go to the table called f, and we see that f of negative 3 is 30. So f of g of 5 is 30. And lastly, we're going to find f of g of 6. So we're going to start on the inner function, find g of 6. I'm going to go to the table. I see g of 6 is negative 1. So if I go to the table called f, I see that f of negative 1 does not exist. So since the range of g, the g of 6 is negative 1, and negative 1 is a member of the range of g, but negative 1 is not a member of the domain of f. Notice that. And so that's why that composition does not exist. F of g of 6 will say does not exist. And the reason why is because the range of the inner function is not a member of the domain of the outer function. So when we do a composition, that's what happens. The range of the inner function becomes the domain of the outer function. Okay, so now we're going to do compositions dealing with equations rather than tables. So we're going to let f of x be 2x and g of x be x squared minus 4. Those are two polynomial functions, and we can do compositions easily with polynomial functions. So before I do this f of g of x example, I'm going to go over to the side over here, and I'm going to use the same two functions, but I'm going to find f of g of 3. Just like we did with the table, but we don't have a table anymore, we actually have two functions. So I'm still going to start on the inside, start with g of 3, and I'm going to find g of 3. So I see g of 3 is 3 squared minus 4. If g of x is x squared minus 4, then g of 3 would be 3 squared minus 4, which is 5. So I'm going to find f of 5 now. So if f of x is equal to 2x, then f of 5 would be 2 times 5, which is 10. So f of g of 3 is 10. Now I'm going to go to the actual equations, and we're going to find f of g of x. Excuse me. So we're going to start in the inner function and find g of x. So g of x is x squared minus 4. So now I want to find f of x squared minus 4. So I'm going to rewrite the f function, and I'm going to take out the x, and I'm going to replace it with x squared minus 4. And I can simplify. So f of g of x would be, if I distribute, I get 2x squared minus 8. Okay, so now I'm going to find g of f of x. So I'm going to do it backwards. Instead of finding f of g of x, I'm going to find g of f of x. So I want g of, and I'm going to write what the inner function is. The inner function is 2x. So I want g of 2x, which means I'm going to rewrite the g function. So I'm going to write x squared minus 4, but instead of an x, I'm going to replace it with 2x. So if we simplify a little bit, we get g of f of x is 4x squared minus 4. Okay, so now we're going to do f of x. Same thing. We're going to rewrite the f function. The f function is 2x. So I want f of 2x. So I'm going to rewrite the f function. And instead of an x, I'm going to replace it with the inner function, which is 2x. So f of x is 4x. Okay, and lastly, I'm going to do g of x. So I'm going to start with the inner function. I'm going to rewrite what the inner function is. The inner function is x squared minus 4. So I want g of x squared minus 4, which means I'm going to write the g function, x squared minus 4. But notice I don't write x. Instead of an x, I'm going to leave it at blank, and I'm going to replace it with what the inner function is, x squared minus 4. So I can simplify this a little bit. I can say I'm going to square this binomial. So I've got x to the 4th minus 8x to the 2nd plus 16, but then I've got this minus 4 hanging out. So I've got g of x is x to the 4th minus 8x squared plus 12. Okay, I'm going to move this down a little bit. This is the last example. Okay, so we're going to go over to the side, and we're going to do another example with, instead of polynomials, we're going to do it with power functions. So I'm going to let f of x be 2x to the 1/2, and I'm going to let g of x be 3x to the 1/3. And so I'm going to find f of g of x. Notice the notation that I use, f of g of x. So I'm going to start with the inner function. G of x is my inner function. F would be my outer function. So I'm going to rewrite the g function. That's 3x to the 1/3. And I want f of 3x to the 1/3. So that means I'm going to rewrite the f function to x to the 1/2. So notice when I say x, I put a big blank. 2x to the 1/2. And instead of an x, I'm going to replace it with what the inner function is, 3x to the 1/3. Then I can do a little simplifying. Not much, but a little. I can say f of g of x is 2 times 3 to the 1/2 times x to the, let's see, I'm raising a power to a power, so I'm going to multiply my exponents, and there I go. And I think that's all I can do there. And then we're also going to find g of f of x. Like that. So we're going to start with the inner function, which is f. So I'm going to write g of 2x to the 1/2. So I'm going to rewrite the g function, 3x. Notice when I say x, I put a blank, 3x to the 1/3. And instead of an x, I'm going to replace it with 2x to the 1/2. So I can do a little simplifying. G of f of x is 3 times 2 to the 1/3 times x to the 1/6. Okay. And then lastly, we've got this little application here. We've got a computer catalog offers computers at a savings of 15% off the retail price. At the end of the month, it offers an additional 10% off of its own prices. So most people who don't really understand percents would think that we're getting 25% off, but I'm going to show you how that's not true. So we've got two functions going on here. I'll call one f and I'll call one g. The first function is that you get 15% off the retail price. So if you get 15% off the retail price, then you're actually paying 85% of the original price. So that's the first function. And then the second function, g, we'll call it g, is that you get an additional 10% off of the price. So you get 10% off of whatever the price is. So if you get 10% off, that means you're actually paying 90% of the price. So we've got two different functions here. And what happens is we take 85% of the original retail price. So where x is the original retail price. X is the original retail price. So we're taking 85% of that to take 15% off. And then whatever number we get there, we're going to take 90% of that. We're going to take 10% off of that new price, not the original retail price, but of that new price. So that means it's a composition. So what we have here, where our inner function is f and our outer function is g, so we have g of f of x here. That's what we have. And if we multiply these together, most people would think that we would get 75% of the original price. That means we would be getting 25% off. But if I multiply 0.9 times 0.8, I get 0.765 of x, which means we're not getting 25% off. We're actually only getting 23.5% off. So we can find the sale price of an $899 computer. We can just take 7. So we want G of F of $899. That's what we want. So that's going to be 0.765 times $899, which is $687.74.